Hello and welcome to this GCSE physics video on moments, where we'll be recapping forces, we'll be talking about what moments are and what affects them, and how to calculate a moment. Multiple forces can be acting on an object. The resultant force is a single force that can replace all of the other forces and have the same effect. A resultant force will cause objects to accelerate, speed up or slow down, or change direction. When forces on an object are in the same plane, they can either be added or subtracted to find the resultant force. Here we have an example of two forces acting on our object. Our object is represented by our orange circle. We have 3 newtons and 6 newtons, and they're both acting in the same direction. As they're acting in the same direction, we can simply add them together to find the resultant magnitude, and that is 9 newtons. A force is a vector quantity, so it needs a direction, so we need to say it's 9 newtons east. Here's another example. In this case, the forces 3 newtons and 6 newtons are acting in opposite directions. So for this, we find the resultant force by minusing the 3 from the 6, which gives us an overall force, our resultant, of 3 newtons. And again, we need our direction because it's a vector quantity, so it's 3 newtons east. Forces can be used to cause objects to rotate around a fixed point. The fixed point is called a pivot. These are everyday examples of objects rotating around a pivot. So every time you open a door, you're using a force to cause a turning effect around the hinges, and the hinges are the pivots. Lifting a wheelbarrow uses a force to cause a rotating effect around the centre of the wheel. And using a screwdriver to open a can of paint, you have the pivot where the screwdriver meets the can of paint, and you use a force to cause a turning effect, and that will open the lid. Rotation around a pivot is a turning effect. Another name for a turning effect is a moment. The size of the moment depends on 2 things: the size of the force, the bigger the moment, and the distance between the force and the pivot. Now this must be the perpendicular distance, so the force and the distance from the pivot need to be at right angles. The greater the distance that you have from the pivot, the greater the moment. To calculate a moment, you multiply the force by the perpendicular distance from the pivot to the line of action of the force. We can shorten this to distance, and we can shorten that even further by using the symbols m equals fd, where moment is m in Newton meters, force is F in newtons, and distance is d in meters. The distance that you need to use is the perpendicular distance from the pivot to the line of action of the force. The line of action of the force sounds complicated, but all it really means is the direction in which the force is acting. As long as the distance between the pivot and the line of action of the force is at right angles, this is the one to use. This question reads, a 0.5 Newton force is applied to the end of a 20 centimetre screwdriver. What is the moment? Well, the first thing we need to look at are the units. Centimetres are not a standard unit, we need to convert that into metres. So we take 20 and divide it by 100 and we get 0.20 metres. Then we need our equation, moment equals force times distance. Once we have that, we substitute in our numbers, and that gives us moment equals 0.5 times 0.20. And we multiply those together, and we get our answer, which is our moment equals 1.0 Newton meters. This question reads, what size force is needed to provide a 1.5 Newton meter moment using a 20 centimetre screwdriver? Well, our units for distance are in centimetres, and we need them to be in the standard unit, which is the metre. So we take 20 and divide that by 100 to get 0.20 metres. Then we need our equation, which is moment equals force times distance, and we need to substitute in our numbers from the question. Our moment was 1.5, and that equals our force, which is our unknown, times our distance, which is 0.20. To get force on its own, we need to divide through by 0.20, and that gives us the expression 1.5 divided by 0.20, which equals our force. If we put that into a calculator, that gives us 7.5 newtons, which is our answer. And that's all for this video on moments. Thank you very much for listening.